Everybody, we're gonna continue addition in the whole numbers. So we talked about addition and subtraction, talking about the properties, commutative properties, associative property, identity property, closure property. You need to remember all that. If you don't remember, please go back to the previous lesson and review all that. We also talked about addition strategies, right? So we use the manipulatives. What else did we do? We talked about the set models. So we talked about number of elements in each set, and they're disjoint, so you can have a union of those two sets and find the number of elements in the set. We also talked about number line models, right? You can skip to the right to add the numbers. The common error is starting from not at 0. Sometimes students start from 1, but that's not it, right? And you don't count the tick marks, but you need to count the spaces of a hop. Also, we talked about adding addition facts, basic addition facts, and the strategies that you can do was counting on, doubles, and making 10, right? And we talked about addition properties, closure properties. What is closure properties? When you have whole number add-ins, when you add them together, the sum is also unique whole number. Commutative property, you commute the numbers around. So when you switch the numbers orders, the sum is still the same. Associative property, when you are adding these two first, it's the same as adding the other two first, right? So the order is still the same, but how we are associating the numbers is different, but the sum is still the same. Identity property. What is identity property? When you add 0 to a number, you still get that number. So we did a practice of that, and what else we did? And then we moved on to addition algorithm, right? We used the base 10 blocks. I showed you how to use virtual manipulatives. You can do the physical manipulatives the same way too. But I strongly encourage you to use the manipulatives before you are dealing with the numbers. Okay, and we talked about standard algorithm. In order to do that, we talked about also partial sum algorithm too. And you can see the connection between partial sum algorithm and the standard algorithm. Now we are moving on to the mental computation and estimation. Why is mental computation useful? Why is it important? Let's watch this video together.
Could you figure out 1,000 take away 1?
1,000. 999.
Could you have done that a different way?
Let me see.
What if I told you that last week I gave that problem to a child, and the child just closed her eyes and then gave me the answer? What do you think about that? What do you think the child did?
She could figure out 1,000 things, and she could subtract 1, so that would equal 999.
How do you think she did that in her head?
Because if it's 1,000 and you would if there's 1,000 things, you could just subtract 1 and that would equal 999.
What if you had 400 things and you gave me 1? Do you know how many you'd have left?
399.
Now, could you do it the other way that you'd like to do it? With a paper and pencil?
This way?
Yeah.
Yeah, you did it.
If you had 400 and you took away 1.
Want to use it on a piece of paper?
Hmm?
Want to use another piece of paper? Or is that okay?
That's okay.
Okay.
So, which way do you like more?
The other way.
Which way?
Thinking your head.
How come when I gave you 1,000 take away 1, you did it on the paper?
Because this I like to do like more harder way. No, like more hard.
And that's a little bit harder.
More challenge.
More challenging way.
Yeah.
Okay.
Okay, so what's your reflection on this video? Yeah, student said she admitted that doing in her head was so much easier. So we get to know mental math is very important, right? Okay, so there are some strategies that you can do to do better on mental computation. You don't have to remember all of the strategies names. Well, it's just names. You don't need to know, but I want you to know all of these strategies because your students can develop, they can create their own strategies, and you need to know how to interpret that, right? So you can help the student to understand math better and learning it better. Okay, so the first one is adding from the left. I think I have mentioned this earlier in the last section. Last video. So usually when you are given the numbers like this, students start adding the first digits first. So going from the left to right. It's just like when you are given money and you are counting them. You are adding two bunch of money together. For example, let's suppose you have $245 plus $107. So you are given two $200 bills, four $10 bills, or $20 bills, whatever. So what would you do? You're gonna start from $1 bills first to count, or you're gonna start from $100 bills first? We start from $100 bills, right? Even if you are not given the money and say I say that, oh, you already had $245 and I'm giving you $107. How much do you have? You can mentally think that, oh, I had a 245 and I got 107, so I'm gonna add 100 first, and I have $345 and 7 more, so I have $152, something like that. So usually students start from left to right. It's very opposite of how to add in standard algorithm. Standard algorithm, we start from the ones place because we need to have the regrouping process there. But when you're working with your head, we barely do that, right? Sometimes we do, but barely. Kami is one of the famous mathematics educator. In her study, she also had shown that. If I have a chance, I could show you that video. I tried to find it. I couldn't find it. Maybe it's copyright issue, so it's not available for public, but there are a lot of studies that students are working from left to right when they are using their head. Okay, so that's one strategy, and another strategy is the second strategy is breaking up and bridging. It's decomposing strategy. So in Common Core mathematics, we use decomposing or composing. So if you have a number and you are breaking that apart, it's decomposing. And if you are putting those numbers together, it's composing. Okay, you can extend this composing and decomposing later in algebra too. So it's a good practice for you, and your students can do it. Breaking up is decomposing, bridging is composing. For example, 67 plus 36. In order to calculate this mentally, you can think about breaking 36 into 30 and 6. right? You are decomposing 36 into 30 and 6, and add 67 with 30 and have 97, then add 6 to it. Then you get 103. That's breaking up and bridging, or decomposing and composing. So try to add 69 and 83. 69 and 83 together using adding from the left strategy. Pause the video and do that mentally. Okay, what did you get? 60 and 80 together is 140, and you have 9 and 3. 9 and 3 is 12. So you get 140 and 12, which is 152. Right? You can do the mentally. How about using this breaking up and bridging method to solve the same problem? We can break either ones, right? So 69 and 80 first, then what do you get? You get 149 and add 3 to it, you get 152, right? Or you can do 60 plus 83, which is 143, and add 9 to it, 152. Either way works. Okay? Oops. Okay, the third method is trading off. Trading off is compensation method, in other words. Okay? So, to make easy number, you can add 3 to 67. Then since you added the 3, you need to take 3 away later or away from the other add-ins. So you can think about if you have 2 groups, like one group with the 67 red counters, and the other group you have 36 yellow counters. Oops. Yellow counters. Then you can give 3 yellow counters to 67 red counters to make 70. But since you gave away, now you have only 33 left. So since you are added 3 there, you are losing 3, subtracting 3 there. That is trading off, or balancing, or compensating. Okay? So you get 67 and add 3 to it, 70. Plus you have 33 left because you took away 3, and adding them together, and you can easily think that 70 plus 33 is 103. I wrote them down here, but you can do this process without writing these steps down, right, in your head. Okay, that's one way. And another trading off could be this. You can change 29 to 30 because 29 is very close to 30, right? But since it's not exactly 30, but you added 1, later you can take 1 away from the sum you have. So 67 plus 30, you added 1, so you take away 1 later. 67 plus 30 is 97, take away 1 from that, 96. That's trading off. Okay? The fourth one is using comparable numbers. We do this a lot of times. Like when you are given your grade score, you can add them together. If you don't have a pen and pencil, you can just see the numbers and which ones are easy to get together to make 0 at the end, right? So like these 130 and 70 together makes 200, 50 and 50 makes another 100, so I have 300 and I have 20 more, so 320 is the sum of these 5 numbers, right? Okay, that's one way. Okay, you can also do the trading off. Let's practice. Pause the video and think about how you can use a trading off strategy here. Okay, I will do, well, you can do it differently, but what I want to do is 67 is very close to 70, so I'm going to add 1 to this one and subtract 1 from here. So that's 70 plus 82. 70 plus 82, 152, right? I meant comparable numbers here, so please fix this. You're going to use comparable numbers. So what would you do? 69 and 31 makes 100 together. So I have 100, keep that in mind. And 3, 2, and 5 makes 10. So I'm going to combine all of these three numbers together. 83 and 12 is 95. And 95 and 25. What's 95 and 25? 90 and 20 is 110. And I have 5 and 5, another 10, so 120. I have 120, and previously I had 100, so 220. Okay. You can also make comparable numbers. So by decomposing another number. So 25 and 75, we know that's 100 because we use quarters, right? If we relate the numbers into money, I think we can understand better. So 25 and 75 makes 100, but there's 4 left. So you're having 4 more to that. That's 104. Yeah, how about this one? Can you do this easily too? Well, 69 and 33. I would change 69 to 70. I think that's the easiest one. Or you can think that to make this as 100, I need 31. So 33 can be decomposed as 31 and 2. So I have 102, right? So that's another way. Okay, estimation. Estimation is very important too, and you may have heard a lot about the rounding numbers, right? So we're gonna talk about that later too, but estimation is not exactly same as rounding. Estimation is very close. Estimation is finding ballpark numbers, right? So it doesn't have to be exact, but it should be very, very close to the actual numbers. So one strategy that you can think of is front end with adjustment. Okay, so we can see that 400, 300, 500 all together is 1200. But because you have more numbers to that, this should be more than 1200s, right? So keeping that in mind, you can look at 23 is closer to 20, 38 and 61 together is very close to 100. That makes 120. So I have 1200 and 100, which is approximately 1320. Okay, that's estimation. Second estimation strategy is grouping to nice numbers. We love nice numbers, easy numbers. So we can see that, well, 23, 32 is about 50, and that's about 50. So together, all three these together is about 100. And I see 39 is close to 40, that's close to 60, so about 100. So together it's about 200, right? That's a nice estimation. Okay, so try this. Pause the video and estimate it really quickly. What would you say? I would say 82 and 21 can go together. So that's about 100. That's about 100. And 53 and 49 is another 100 about, right? And what else is left? These two are 40, about 60, so about 100. So I would say it's about 300. Okay. Estimation 3, third one, clustering. Clustering. What does clustering means? You're gonna cluster grouping the numbers together around a common value. This strategy is limited to certain kinds of computation. In this example, the numbers seem to cluster around 6,000 because you look, 6,200 is very close to 6,000, little more than 6,000, little less than 6,000, more than 6,000, about 500 more than 6,000, about 500 less than 6,000. So compensates, it's about 6,000. So we can say that all of these 5 numbers can be clustered as 6,000, and I have 5 of them. So we can say it's approximately 5 times 6,000, which is 30,000. Okay. And rounding, we talked about rounding a lot of times too. So rounding is a way of changing numbers so they are easier to handle. Rounding enables us to find approximate answers to calculation as follows. So this is when we round this to nearest thousands, it's about 5,000, about 3,000. So together it's about 8,000. To make it close, yeah, and that's very, it's not very accurate. It's a little bit far from the actual number because I rounded nearest thousands. If I do round nearest hundreds, it's gonna be a little bit closer to the actual value. If I rounded nearest tens instead, it goes very, very close to the actual value. Okay, and so on and so on. Okay, so here are some examples of estimation. Do the two pandas together weigh more than 500 pounds? Let's think about it. So I have one panda, female panda, 255 pounds, and male panda, 329. What would you say? How would you round it? So if you are rounding this to 300, and that's also about 300, it's gonna be about 600, right? That's kind of a lot. But if we are rounding 320 instead, rounding nearest tens, this is gonna be about 260, and that's about 330. So 260 and 330, what is it? It's gonna be 200, 300, 500, and 60 and 30, 90, 590. So it is more than 500 pounds, right? Either way, whether you are rounding nearest hundreds or tens, it's gonna be similar. Oh, this one is a different method. Comparable numbers. So 255 is close to 250. That's close to 325. So you are making this number higher and this number lower by about the same number, then it's gonna be very close, right? And that is of course greater than 500. So yes, together they weigh more than 500 pounds. Okay, so here are the rock collections. Dina had 350 rocks and Carl have 345 rocks. Let's say Tina, I don't know, has 377. Can you estimate the total number of rocks? How would you do that? There should be several ways, right? I think I can use clustering, 300 around 350, 350 around 350, little more than, little less than. So I will just do 350 times 3. How about you? If you have a different idea, share that with us. Great. And next time you're gonna work on section 3 of chapter 3, subtraction. So read the textbook and do your homework and be prepared for the next section. Have a great day, guys. Bye.